Hi guys, welcome back to my YouTube channel Code Ground, the battleground of coding. So today we are going to solve the daily coding challenge of October 6th, that is swimming in rising water. So let's see what the question is. Uh, you are given an into an integer matrix grid where each value grid of ij represents the elevation at that point I comma j. So uh, at 0 comma 0 the elevation is 0, at 0 comma 1 the elevation is 2, at 1 comma 0 the elevation is 1, and at 1 comma 1 the elevation is 3. Okay, what do we mean by elevation? Elevation is nothing but uh, the height at that point. So yeah, uh, it starts raining and water gradually rises over time. Okay, at time t the water level is t, meaning any cell with elevation less than or equal to t is submerged or reachable. Okay, so after 2 seconds, this cell, and this cell will get water accumulated over them, and those cells are submerged. So they can be reachable. Okay. You can swim from a square to another four directionally adjacent square, and only if the elevation of both squares individually are at most t. Okay, if in simple words, if you can go from one cell to another cell, if both are submerged. Okay, you can swim infinite distances in zero time. Of course, you must stay with the boundaries of the grid during a swim. Okay, return the minimum time until you can reach the bottom right square n comma 1 n comma 1 if you start at the top left square 0 comma 0. Okay, so we need to return the minimum time to reach from 0 comma 0 to n minus 1 n minus 1 cell. Okay, so what do we do now? uh, so first, uh, our approach will be a simple BFS. We'll use a priority queue to store the most most least height, and then we'll pop the priority queue, and then we'll check for all the neighboring cells, and then we'll proceed in the same way. Okay, so let's do that. uh, 10 equals to grid dot length. Okay, uh, next let's have directions equals to uh, 0 comma 1, which is going to the right cell, uh, 0 comma minus 1, which is going to the left cell, and 1 comma 0, which is going to the downward cell, and minus 1 comma 0, which is going to the upper cell. Okay, uh, then we'll have Boolean array visited, which is of length n into n, which is of size n into n. Got it. Uh, Now we'll have a priority queue of integer array pq equals to new priority queue. Uh, uh, we are going to have the reverse max heap. Yeah. So then we need to add the 0 comma 0th cell because we have already reached that cell. Uh, we need to also add the coordinates. Yeah. Then, uh, then we need to mark the 0, comma 0th cell as visited. Yeah. Mm, and we need to have the result variable is to 0. Yeah. Next, while not of PQ is empty, uh, we need to perform the BFS. So int array current equals to PQ dot poll. Mm, yeah, and this will be the time equals to current of 0. The row will be current of 1. The column will be current of 2. Great. Yeah, and we need to declare we need to change the result variable because we need the maximum time. So math dot max of result comma t. Yeah, great. And yeah, then we need to check for all the four directions for int array d in directions. The new row will be row plus d of 0. New column will be column plus d of 1. Yeah. Uh, Here we can add condition if row equals to n minus 1 and column equals to n minus 1, we can return the result. Yeah. Uh, and new row, new column. Then we need to check if those are in bounds. New row is greater than or equal to 0 and new row is less than n and new column is also greater than or equal to 0 and new column is less than n, and most importantly that cell should not be visited of new row comma new column. If it is not visited, yeah, then it should be we should mark it as visited. A new column equals to true, and we should add the new cell into the priority queue. New int of mm, grid of new row comma new column and new row and new column. Great. And then we can return the result. So yeah, it should work now. Let's see. Uh, Expected boolean. Oh, sorry, it's new boolean. Mm, mm, what's the error? Oh, we shouldn't be writing this because it is not uh, a single data type, right? So we can write like this. Uh, okay, I guess this should work now. Hmm, great. Yeah. So let's go. Uh, great. Yeah. This is the solution, and this is how we should be solving this problem. Uh, please, if you like the video, do make sure to like, comment, and subscribe the channel. Uh, and yeah, thank you.